Hello, welcome back to Blender Sushi Live Coding. So we have seen how we can create kind of like a voxel array using Blender modifier in the previous live noding. Um, in this video, I'm gonna take you through the creation of the like a 3D array of voxel using Sverchok. So there are many ways to do this, but I'll do something that's a little bit different. I might actually use Sverchok Nestiness. Nestiness in Sverchok is something that's quite unique, and it's not always easy to explain, but it's easier to actually just to use it. So I'll start with range float. So we're gonna generate like a voxel, right? Like a 3D grid of points before we create a box. So I'll start with range float, and I'll use vector in because I'm gonna convert this value. This is like a list of value into a list of vector value. I'll show you with a stethoscope what it's gonna look like. So by default, range float really generate value between 0 and 10 with a step of 1. We can change it to this one. Instead of range, change it to count, and we can generate like as many number as we want between this start and stop value. So that's a floating value list, and if we plug into the vector in, we're gonna generate a bunch of vector value, and with a vector value we can really just use a viewer draw, and by doing this we have like a bunch of points, and these points are similar to the points being generated using line. I'll save this real quick. This is a SV 3D grid voxel, and this is kind of doing it the hard way, but also like kind of like a in a magical kind of way, Sverchok way. So imagine if you want to create a grid in Sverchok, how can you do this? There are many ways to do this. You can apply like a matrix transformations, but you can also use Sverchok Nestiness. Nestiness, I mention it again. What is Nestiness? This is a I think if I just plug this, like I just make a duplicate of the range float, and if I plug this into the Y, you will see that it's gonna generate this point is kind of going diagonally, because now we have value that's kind of like 0, 0, and then 0 0.1, 0 0.1, 0 0.2, 0 0.2 for the X and Y. But if we use like a Sverchok Nestiness, I think we can use a list level. Maybe not list level, actually list split is more what it is. You see we have a grid. Why is that? Yeah, this is not quite easy to explain, but if you look at the nestiness, look at the bracket here, we change it from something that looks like this, you know, like this. Don't worry about the double bracket, that's just like a Sverchok thing. Just look at the number. This guy compared to this guy, this one is being nested. So once it's being nested, what's happening is like Sverchok gonna do something clever in here and gonna generate this this grid. So yeah, that's actually really powerful, and in fact we can do this multiple times. Let's say so we have this like a plane kind of grid. If we want to multiply it across vertically, I believe we can just list join this guy. So we need to join it first, and then if we bake it, you see we get like a grid of points. But if we do one more thing, like move it up, we're gonna, for the vector, now we are dealing with vector, we want to kind of duplicate it up, so we use line and then duplicate it up in the z-axis. We plug this into this guy, and suddenly like something like magical happening, similar to the one we have before. We just need to use a list split, and I believe scale this split, and then let's make like 5. So we have 5 data here, 5 nestiness, but we also need to use a list repeat. So if I'm doing this correctly, okay, there you go. That's the result I was thinking about, I think. So we can maybe there's a slight error. Actually, no, with the number. See, currently we have 5 and 5. If I change this to 8, we have 8 and 5. It doesn't work like that. We need to make sure the number is the same for the nestiness. So now, okay, now it's working. So we have control over this guy, the X, and then the Y, and the distance of the Y, and then we also have control over the vertical vector. So yeah, this is it. Actually, this is one example of nestiness. It's hard to explain what's going on, but you try and make this yourself and see. It's actually quite very powerful kind of concept. Now, if I join all this, you know what happened? This is like we have a bunch of vectors, like a 3D matrix of vectors, and then what can we do with this? We can simply, for example, use a box, plug in the box like that, and then plug this voxel matrix thing into the matrix, and we have a grid of box. So yeah, this is one basic example of Sverchok, but I think it's really powerful. If you understand this, you probably will understand Sverchok a little bit better. We have 1080 vectors. We have 1080 boxes at the moment. It's quite a big number. I'll make it a bit smaller. So 3 by 3 by 3. We can space this a little bit better. The line also have some kind of spacing. Okay, so we know that we can randomize this guy. Randomize input vertices. That should work. And with XYZ, you see you can randomize this guy. But of course, vector into the matrix is like automatically randomize the position. You can also use I think this matrix in like that, and use a vector in the scale, make it something like that, and then put a random vector into the rotations. How many we have? 27. Randomize the seed, randomize the rotations. So we have this. That's like a super complex stuff, but it's becoming so easy to do. I guess it's I think that's really powerful. And so if we increase the number, so 6 by 6, 36 times maybe 10 across in the line. Line is okay, 10. 6 by 6 by 10. We have 360. So 360 random value. And we have this. Let's space this a little bit better. There you go. That's like a random structure generated using Sverchok, and everything is like super easy to create. And then if you wanna bake this out, if you hit bake, this is gonna generate 360 objects. That's probably not what you want. You want to use mesh join. Maybe mesh join matrix apply. So this guy is actually probably what you want. Cut everything. Now vertices. polygon, matrices, and join them all, and you should get a single object. Bake it up. You have a single object based on this one. So there you go. That's the magic of Sverchok Nestiness to generate a 3D grid, voxel grid. It's very similar to the previous LIVENODING, where I use like array modifiers to generate it. But with Sverchok, you really have more controls over every single boxes. You can randomize the scale, etc. And of course, you don't actually need to use boxes. You can use anything. Here, if you wanna save the step actually here with a range float and list split, etc., etc. If you want to cut that, you can actually just simply use a plain grid here, and that's still gonna work. I'll show you. Maybe I'll take a screenshot first for the video. So this is one example. Actually, it's nicer with the matcat. A bit more colorful. Okay, I'm gonna save this. So instead of using all this vector stuff and list join, we just cut it here, plug in the grid. See, with the grid, we just control the grid, and it will actually generate our 2D grid. And if you have like extra objects there, that's because we have too many objects. The count here needs to match the number. So 360, how many do we have? 60 count. Maybe I did something wrong here with the number. 160. Okay, 160 then. There you go. That's with a plane, you can easily control the X and the Y, and then the stepping. So yeah, that's two possibilities there. Whether you start from range float or you just use a plane for that. Okay, hopefully this one is useful for you. If you have any question, feedbacks, suggestion, let me know in the comment section below. Thanks again for tuning in. I'll see you in the next video. Bye.